Hello, my dear pilot friends, preparing for CPL or ATPL or the airline examinations. Here I am in the series of my navigation numerical tutorials. We have done numericals on the instruments, magnetism, compasses, and gyros. And we have learned the procedure for earth shape, nautical mile, statute mile, what is delayed, delong, and how to convert it into distance, what is the distance, units of distance, and their relationship. Today, we will cover a little bit about what is convergency, conversion angle, etc., related to the surface of the earth and the maps and charts. And after which next lesson, that is in the next lesson, we will go over to the maps and charts, their construction, and the numericals asked in maps and charts. Now, I hope you have done the numericals which you have been doing so far, and you have been keeping pace with those numericals. Let me today take you on to back to the Earth. The Earth, as you know, is not a perfect sphere, oblate spheroid, on which for the purpose of reporting position, we have created a network of vertical circles and horizontal circles. This network is imaginary and drawn on your maps and charts. And it is called graticule, Graticule. We will study this again, further study this network and find out some more definitions connected with the Earth. Now, let's say this is the Earth. This is the equator, a great circle dividing the Earth in two parts, northern hemisphere and the southern hemisphere. And parallel to the equator are small circles, and at the interval of 1 degree each, and 1 degree is then divided into 60 minutes each. So from equator to the pole, there are 90 degrees, either pole, North Pole or the South Pole. Similarly, the vertical circles, we draw a circle 90 degrees to the equator. We draw 180 circles to the east, 180 to the west at 1 degree apart. Total will give us 360 degrees. These are numbered 180 to the east, 180 to the west, and one of these is named as the prime meridian, from where the readings are taken. For latitude, the readings are taken from equator, north or south in degrees and minutes. And for longitudes, we take readings horizontally and in degrees and minutes up to 180 east or 180 west, which is the anti-meridian of the Greenwich meridian. Meridians join North Pole and the South Pole, and these are great circle. Meridian is a semi-great circle. Meridian and its own anti-meridian combined makes it a great circle. Not meridian and any other meridian. Meridian and this meridian's anti-meridian combined makes it a great circle. Okay. What do we do? What are we going to use it for? We will discuss it later. Right now, we are learning the basics of the surface of the earth and the graticule drawn on it. Like you study A, B, C, D, and then you study the grammar, and what use will it be? You come to know later on in your life when you start using those things for your daily official work. Now, let's get back to the navigation and the earth. What is a great circle? Great circle is a circle on the surface of the earth whose center and radius are same as that of the earth. For example, this is black one, this is one great circle. Equator is another great circle. The properties of the great circle are that between any 2 points, let's say X and Y on the earth, only one great circle can be drawn. Okay? And great circle divides the earth into equal halves. If the points are diametrically opposite, like North Pole and the South Pole, then we can draw any number of great circles passing through these points, but these 2 points should be diametrically opposite and called antipodal point. Otherwise, we can draw only one circle joining 2 places on the earth, and therefore, great circle is the shortest distance between these 2 points, but please remember, it does not give you a constant direction when you are flying along a great circle. Shortest distance, yes. The great circle changes direction. Great circle is concave to equator and convex to the nearer pole. This is the northern hemisphere great circle. And this is the southern hemisphere great circle. If we draw another line, imaginary line, from X to Y, cutting all the meridians at the same angle, since the direction is measured from a meridian, that it defines us the north. Since it cuts all the meridians at the same angle, it will give us a constant direction, but not the shortest distance. Rhumb line is flown when you want to fly a constant direction. Equator and meridians are the examples of great circles, which are also rhumb lines. This is also a rhumb line. So I'm flying on a meridian. This side will be north, flying downward. This side will be south. Okay. And a constant direction, since meridians are also rhumb lines. Any other great circle will not be a rhumb line. Parallels of latitude are small circles and parallel to equator. Since equator cuts all the meridians at a 90 degrees angle, they will also cut all the meridians at the same angle. They define a constant direction. They lie along east or west. But that's not the shortest distance. So we will study these and find out what will be the difference in distance between these 2 points if I fly a rhumb line or a great circle. Okay. Now, meridians converge to each other. Here also. Draw another diagram. If I draw the shortest distance from point P to Q, this will be called a great circle track. The track is measured at the meridian. This is the track. Here, this will be the track. Here, this will be the track. And at this point, this is the meridian. And so this will be the track, great circle track. But you will now find out that this track and this track are not the same. This is bigger track. And why has the track increased? Because I'm traveling in a clockwise direction. Meridians are shifting in the anti-clockwise direction while I'm flying. So this is the meridian here now over a period of time. This meridian has shifted direction here. And then this angle is called convergency angle. If I draw a line parallel to meridian A at this place, then this was my original track and my current track is my original track, that was this angle, plus the convergency. So convergency is inclination between two meridians at a given place. Here, I have taken inclination between meridian E and meridian A. So this is the convergency between meridian A and meridian E. At the equator, these meridians are parallel to each other and there is no inclination. If you transfer one meridian this side, left, right, it will not make any angle. But at the pole, it makes a maximum angle, and that is your change of longitude in degrees. So that angle convergence is the angular difference between two meridians at any given parallel of latitude. At equator, it is 0. At pole, it is equal to dlong, and therefore, convergence on a particular parallel of latitude will be dlong in degrees. And since the value is increasing from equator to pole, we multiply with this with the sign of the latitude. Now, remember, great circle is a constant. Great circle is the shortest distance, but not the constant direction. Whereas rhumb line gives me the constant direction, but not the shortest distance between two places on the earth. Now, let me free some space and we can go to the next concept. Just a moment. Now, let's take a fresh diagram. These are the meridians in northern hemisphere. At equator, these meridians are parallel to each other, and then they converge onto the southern hemisphere. These are the parallels of latitude. Okay. If I want to fly between these places A and B, then this track, these parallels of latitude cut the meridians at 90 degrees at the same angle. So when I'm flying on a parallel of latitude, my track will be either 090 or 270. And if I continue flying this track, I will come back to my original point after having gone through entire 360 degrees. Only thing is that difference in distance will be there. Here it is. If I fly at equator in the direction of 090 or 270, let's take 090 for the time being, I will cover the entire Earth and come back to the same point. After covering 360 degrees into 60 minutes for each, dlong in minutes I will cover is 21,600 minutes of dlong, and that will also be your distance in nautical miles. But as I go to the higher latitudes, parallels of latitude, this distance keeps decreasing, and the distance east to west, like I told you before, called departure, is dlong in minutes, or change of longitude in minutes, multiplied by cosine of this latitude, cosine of phi. Well, those of you who would like to go around the earth, go ahead, no problem. But if you go around the earth, don't start here around the equator, and you will have to travel 21,600 nautical miles to cover the entire earth. You want to go around the earth in the shortest possible time and distance, stand on the pole and take a 360 degrees turn. In a zero distance, you would have covered all the 360 degrees meridian. Just take a step down and go around. How easy it is to go around the earth. Then you can come and tell your friends that I've been around the earth and I'm back here. But shortest distance will be near the pole, or at the pole itself will be the shortest distance. So this is distance east-west called departure. 30 seconds, and let me be back with you. Let's take place A and B, place A and B, or call this A, this B. If you are flying from A to B and on the same parallel of latitude, this will be your track 090, or B to A 270, and remain on the same parallel of latitude. Let's say this is 60 degrees north, and you will be flying a constant direction. But if you want to fly the shortest distance, then draw a great circle track. If this is the northern hemisphere, this will be the great circle track. And if it is the southern hemisphere, this will be the great circle track from A to B. If you know the rumb line track, you can find out great circle track. If you find great circle track, you can find out rumb line track. This is your north. In the northern hemisphere, this will be your great circle track, and this will be a rumb line track, which will be more. In the southern hemisphere, this will be your rumb line track, and this will be your great circle track. Great circle track will be more. And how much more or less is the angle called conversion angle. Now, if you fly the great circle track, you will cover the shortest distance. The value of conversion angle is equal to half of the convergency. Half of convergency is your conversion angle. Convergency is dlong in degrees into sine of the latitude. And if these two places are on different latitudes, A and B, then take the sine of mean latitude or mid latitude. So that's a mean value. Don't take the literal sense. There is nothing mean about it. Mean means if one latitude is 30 north, other is 40 north, mean latitude will be 35 north. Okay, not at all mean, call it mid if you feel like. So This application of convergency and conversion angle we will be using while plotting bearings on a chart on which a great circle is a straight line and you have to draw a rhumb line, or rhumb line is a straight line and you have to go a great circle track. That we'll be using in maps and charts and plotting bearings in radio aids. Now let's avoid confusion, if any. We have used dlong here also. We used dlong between two places in our finding out the distance, converting dlong into distance. That is for finding out departure. There also we use dlong. Now please remember and make no mistakes. Change of your distance east-west called departure is equal to dlong in minutes between these two places. Direction does not matter whether you are east or west. You are only finding out the distance, which will be same whether you travel towards east or west. dlong in minutes multiplied by cosine of the latitude. Whereas conversion angle is half of convergency, it's an angle. So we will take dlong in degrees now and multiplied by sine of the latitude. This is where people make mistakes. Remember, it's an angle. So this also, dlong will also be an angle. Here, this is a distance. And so we will take dlong in minutes. If your latitude is, let's say, 30 degrees, these two places are 30 degrees latitude for the mean latitude. And their dlong in degrees is 15 degrees and 45 minutes. For dlong in minutes, you can do it either on the calculator or manually also. It's not going to take you long. Each degree is 60 minutes. So 15 into 60 is 900 plus 45 minutes. So your dlong in minutes will be 945 minutes. Multiply 945 with cosine of 30 and you will get the departure, that is distance east and west. Whereas if you are finding out the conversion angle, I need dlong in degrees now. What will be the conversion angle between these two places, which are 15 degrees and 45 minutes apart, dlong. So dlong in of 15 degrees and 45 minutes can be written as 15 decimal 45 divided by 60. That will be 0.75. Now here I will write down dlong in degrees is 15.75 degrees. Now multiplied by sine of 30, not the cosine, sine of 30, and you will get your conversion angle. There are various numericals connected with these concepts. Number one, he can give you place A and B, their coordinates, and ask you to find out departure. He can ask you to find out convergency between these two places or conversion angle between these two places. Or he can give you the coordinates of place A, let's say 18 degrees 45 north and 38 40 degrees west. And now he says, this is place A, find out place B, which is east of place A. Now I find out the dlong in degrees and minutes. He will give you the distance. This place is 900 nautical miles. Okay. Now I know the departure. I will find out dlong in minutes, convert it into degrees and minutes after applying this formula, and then apply that here. If I am at 3840 west and going towards east, my longitude will decrease. If the change of longitude is more than 3840, after 38 degrees 40 minutes, I will cross the equator. And if remaining dlong is 2 degrees and 30 minutes, now I will travel 2 degrees 30 minutes east. And that will be my new location. I started from here. Connected with these 2-3 concepts, if he says find out the conversion angle, he can give you the latitude. He can give you the departure, then find out dlong in minutes, convert it into dlong in degrees, and convert it into conversion angle. So these between these dlong in minutes, degrees, cosine theta, and cosine phi and sine phi, and phi, remember, is your latitude. You can get a couple of numericals. And these numericals we will practice in a separate lesson. Maybe the next lesson, we will first finish the numericals concept connected with these concepts, and then we will proceed forward to the next set of lessons in maps and charts and flight planning, and a lot of it still to come. So these are the concepts we will be applying for our next set of lessons, along with the dlong, delat, and how to convert this into distance, north, south, east, west, etc. And how to use them for finding out conversion angle. Okay. And if this is going to you, conversion angle is given to you, you can find the dlong, then he can ask you to find out the second place. This is your place A, find out place B. And application of these in the numericals we will do in our next lesson. If you are a little confused, could be, there is a possibility that dlong, delat, everywhere it's coming in. And what do I do with this great circle, drumline, etc.? So I suggest any lesson which you are finding that I'm getting confused, the only way out is see that video twice, and if need be 3 times. You can sacrifice for the time you are studying for your CPL, ATPL. If your focus is towards achieving your target, look at your target. Your target is CPL, ATPL, and a Boeing or an Airbus cockpit, then work towards that. And instead of watching TikTok videos, you can watch your navigation videos. And I can promise you, after some time, when you start understanding them, you will find it more lively than your humorous videos. They take away a lot of your attention, leaving you with little time for your future and career. Right? I do not mean to say 24 hours you keep on studying. Yes, every person needs rest and recreation, but divide your time gainfully. If your aim is if you want to go into mediums of TV, movies, and the media, yes, go ahead and watch those videos and practice them. If you want to go into aviation, then my videos will be more useful than those dancing videos. I hope I have not upset you, and you will take it in a lighter vein. I'm not trying to give you a moral advice that only remain with me. I don't go anywhere else. Enjoy yourself, but keep pace with me also. Good luck. All the best. This is SK Booty signing off for the day. Till we meet again. Good luck. All the best. Happy landings and happy studying.